Ooh. Hello, hello. How's everyone doing? Very first class. Speaker सही कर ले और device. I will pause chat until the class ends. I see a few Notion docs, so they let me open 2 and 2, 3. Life in Suji.in seems down. The other one looks okay. I think crazy uify.com. This one looks good. wpool. Let me just share my screen and show what I was looking at. We'll start in another 2 to 3 minutes. And let me just close my WhatsApp here. Close. That's the slides, and we're good to go. Hello, hello. Welcome everyone. Very first class. Hopefully you guys are excited.
is an image. Season there. So under UL
It's slightly simple class, but once people can also have something and some call outs before we begin. I'll look at projects if you guys want me to at. I'm aiming at 9:15. I think this is one. good. The front end looks clean, especially if you made this without AI. So happy to, I mean, not happy to talk about the front end. There's one guy called Abhyuday. I need to refer from Super30. and then we can talk. उसके बाद front end का तो कोई नहीं है specifically in Super 30 I think, but वही थोड़ा elegant. I'll show you some examples today of elegant front ends. We can go from there. The slides for the day are over here, mildly repeated from the warm-up videos. Some extra things added and a bunch of assignments. If you've done the warm-up videos, this should be a very simple class. I forgot to start recording locally, so let me do that. Hello, hello. Yeah, I think we're good to go. All right, recording has started. What I was saying was today is a very simple class, HTML and CSS. We're not going to touch JavaScript. In fact, the first 2 weeks are probably going to be very easy. So an auxiliary introduction for today's first information slash learning class is going to be, we'll go slowish for the first 2 weeks. When I say slowish, basically means one class for HTML and CSS and one for the syntax, basic syntax of JavaScript. And then we'll actually mildly easy class today, primarily only for beginners. But I am hopeful most people know the syntax of JavaScript, and hence we might just do async JavaScript today as well. These are the official slides. I am hoping we can finish everything today, even if it's a longer class. Or if it feels a little jarring, then we'll go a little slow, and what we'll do is we will finish half of this today. We'll do async JS next week, but I'm hopeful you guys are pretty smart, and this should be doable in one class. That way we can do DOM manipulation next week, and then we can do interesting bits the week after. So could you open these slides? Let me also share my screen here. And how many of us already know all of this? Maybe not all of this. How many of us know up until this point what are functions in JavaScript? Actually, the whole thing. How many of us know everything that's written on the screen? That includes callbacks, which is the more difficult bits. Async, await, maybe not promises yet, but some intuition towards promises. And the architecture of JavaScript. Have you gone to this website before? Do you understand what the call stack is? What is the event loop? I'll do a poll, and based on that, we'll decide the pace of the class. Do you already know everything that's mentioned on the screen? Yes or no? Do you already know async JavaScript, the architecture of JavaScript engine? So that's a 60% no, and 50% no, 60% no, yeah. So we'll go slow. We'll take it step by step. But still 40% already know this, which is pretty cool. I would like to give you guys an assignment for the 40% before we start. There are some assignments in the last week, this thing, plus there would be more. Let me quickly talk to Rahul and see. By assignments, let me share another assignment in a bit, in like the next 10 minutes, in the middle of the class, for people who think this is very easy. Or you can drop off and I'll put the assignment somewhere in Discord, I guess. You can try to do just the assignment. It's not, the JavaScript is not just on JavaScript. The assignment is not just on JavaScript, it's on a few more things. But if you know this much, I'm hoping you also know Express, MongoDB, Prisma, SQL. So the assignment will be on that. Everything that's mentioned over here is probably the first 3 months of the school in one class. I repeat, 3 months for a complete beginner squeezed down into one class. I think that's how it should be. I think for this online cohort, we expect people to be a little more actionable and not very handholdy. A lot of practice you should do in the upcoming week. And if you're able to understand everything, that's 3 months of a sprint, or whatever, the tuition fee of 100 school divided by 2 in a small single 2.5 hour class. If you can digest all of this very quickly. For beginners, it's usually a little hard, but I think if you practice, you'll be fine. We kick things off with the basics of JavaScript. It's a JavaScript 1.1 class. JavaScript is the primary language in which you'll be writing most of your code. Probably 99% of your code will be JavaScript. 1% will be CSS. It'll be TypeScript, it will not be JavaScript, but TypeScript is a very easy curve if you understand the very first language, which is JavaScript. It will be very easy to digest if you have done coding in a different language, that is C++ or Java for DSA. If you have not done any coding, it will be a slightly more harder class. We will kick things off. Web development. But we're learning, in the specific part of this cohort, web development or full stack development involves writing a lot of HTML, CSS, and JavaScript code for websites for the front end. If you've heard of React, if you've heard of Next.js, if you've heard of Astro, all of these frameworks involve you writing JavaScript for the front end. We're just focusing on the front end, let's say in this class, even though we'll do a little bit of backend also. But generally, when you're doing web development, and if you're doing it in the MERN stack, then for everything you need to write a lot of JavaScript code. Historically, and even to today, to some extent, browsers only understand HTML, CSS, and JavaScript. That's the very first beginner intuition to make. Okay, when you open a browser, open any website on the internet, it could be as something as complex as Google Maps or google.com, something as complex as a website like this, which is a search engine, or chatgpt.com. Most of the website code, at the very least, not most, almost all of the website code, the front end code, the website that you see, is 3 languages: HTML, CSS, and JavaScript. You can confirm that by going to google.com, right click, I repeat, go to google.com in your browser, right click, click on inspect, and when you click on inspect, repeat, go to google.com in your browser, right click, click on inspect, and when you click on inspect, you will see a bunch of what are called Chrome developer tools. I repeat, right click, click on inspect, open the Chrome developer tools tab. For some of you, it will open at the bottom like this. For some of you, it will open on the right like it was open for me. You can click on the network tab over here and refresh the page, only to see a bunch of requests that go out, a bunch of files that we get from a server. The first file we see over here is a HTML file. It's a very complicated HTML file, but it is indeed an HTML file. The second file we see over here, it's a bunch of font data, so that's probably CSS. A JavaScript file. What is WOF2? It is a font file. This is a static, again, a lot of JavaScript. Even though the syntax or the extension doesn't say .js, this is a lot of JavaScript code that is written over here. What is this one? A lot of CSS that is written over here. What is this one? A bunch of, this looks like HTML, but I would think this is HTML inside JavaScript or something else. This is probably just some variable or probably some partial JavaScript, I would assume. No preview over here. Keep going down. There's something else, ignore what this is. These are API calls. But most of the things that you see over here, at least initially, a bunch of other things happen later. But the very first request is a request to HTML file. A lot of code is JavaScript. A lot of other requests go out, but a lot of these requests aren't, files that are coming from a server. The files that are coming from Google, when you go to google.com, are HTML, CSS, and JavaScript files. We understand hopefully HTML and CSS from the last class. Today, what are we learning? We're learning JavaScript. If you open google.com, what shows up over here is a combination of HTML, CSS, JavaScript, and of course a bunch of images. This, for example, is an image. This H avatar that you might see might be an image, might be something else, might be a div, with H written in the middle, or this thing that you see over here is an image, this thing that you see over here is an image, so on and so forth. Any website that you go to, HTML, CSS, JavaScript, three things that you need. The most complicated website you can look at today, it's front end, it's structure. You can recreate using HTML, CSS, and JavaScript. You don't need a fourth language. That's what your browser understands as well. If you write some C++ code, you can't execute it inside the browser. There are ways to do it, but 99.9% of websites will not execute C++ code or Java code or Rust code or Golang code inside the browser. The browser will only understand HTML, CSS, and JavaScript, three files. A few callouts for people who already know some languages. You might have heard of React or Next.js. They are frameworks. Your browser doesn't understand React. It understands HTML, CSS, JavaScript. Whatever code you write in React or Next.js, in the end spits out HTML, CSS, and JavaScript that your browser does understand. So React isn't something that's built into any browsers. It is not part of a browser spec. If today you are creating a browser, you will not write code to understand React or Next or any new framework that comes today. You will only write code to understand HTML, CSS, and JavaScript and render a file. When you run on your C++ code on LeetCode, if you've gone to leetcode.com, tried a few DSA problems, when you click on submit, the C++ code does not run inside your browser. I repeat, the C++ code is not being executed on your machine. The C++ code goes somewhere else and it executes in some other server. And if you get a TLE or a wrong answer or an accepted, this response is coming from a server. It does not run in your browser. If you turn off your internet and try to submit on LeetCode, it will not work. What does that tell you? It tells you okay, when you submit on LeetCode, your browser isn't running some code to execute that C++. It is supposed to go somewhere. And if your internet is shut off, it can't go over there, which is why that is another thing that tells you C++ code does not run inside the browser. If someone asks you in an interview otherwise, what all languages does your browser understand, interpret? Your answer is HTML, CSS, JavaScript, and WebAssembly. Now, this fourth thing is something more important and allowed inside browsers. A lot of languages like Rust and C compile down to WebAssembly. What is WebAssembly? Do we understand assembly? Your C++ code generally compiles down to assembly, which is what your operating system can understand, interpret, and run. WebAssembly is some code that you can write in this language and compile it down to WebAssembly. Your browser can understand this, and in some specific use cases, for example, if you are doing background removal on Google Meet, if you go to googlemeet.com and select, I want to remove my background, I want to create a fancy background behind me, the background removal process runs in a web worker, and a lot of times that code is written in other languages like Golang or C and not written in JavaScript. That background removal process is happening using WebAssembly. So there are ways to run C, C++ in some minute specific use cases. Other than that, mostly your browser only understands three languages. We have understood two of these languages. Today, we're understanding the third one. Before we proceed, we'll do one thing that brings Replit down every time. I'm hoping most of you have Node.js installed locally. If you don't, which is fine. For the people who do not follow these steps. For the people who don't, jo pehi baar code kar rahe hain, you're coding for the first time, then please go to Replit. Hopefully you have the practice that we're doing today. You can do either on Replit if it opens. Seems like it is not opening for me. Or you can do on your own machine using Node.js, which is a slightly tedious process. So let's not get into that today. Or you can right click, click on inspect, open console, write clear over here, press enter. Sorry, write clear and then bracket open, bracket close. I repeat, clear followed by bracket open, bracket close. Replit starts. Actually, it isn't starting for me. It did start for me. Let me quickly create an account on replit.com. I would urge you to do the same if you want to have a smooth process, like smooth class today. And if you don't already have Node.js installed locally, if you have Node.js, open, keep explore, click on apps, click have changed. Doesn't repeat our code in. Or if you have Node.js installed locally, plus 2, because this is a second class. How am I creating a folder? Using the terminal being fancy, but you can always open a folder over here, right click and create a new folder. And I'm going to open this class 2 folder in my cursor. You can open it in VS Code, cursor, NeoVim, anti-gravity, whatever your poison is. I have opened a fresh folder in VS Code, sorry, in cursor. And I'm going to write VS Code just like in the last class. We created, if you remember, an HTML file. In the last class, if you remember, we created a CSS file. Today, we are not doing HTML or CSS, we are doing JavaScript. So I've added a JavaScript file. Now the problem is, we will write a lot of JavaScript code here. For example, this is the simplest JavaScript code that you can write. Console.log there. To run it locally, you have to open the terminal and run node index.js. The problem is you need to have Node installed on your machine. How did I open the terminal? You can click on File, New Terminal somewhere here, or you can just press Command J or Control J. To open the terminal, press Command J or Control J, node index.js. You can either write it here or you can write the same code over here, but it's a little hard to interpret it here. So I'd suggest you have the local setup ready. How do you install Node.js? Install Node.js on Mac or Windows or whatever your machine is. Go through these steps to install Node on your machine. I am going to now ask everyone if everyone's ready with this setup, and I hope you are. Hopefully, most of you are ready with this setup only. If 90% or 92% are ready with the setup, I'll just proceed with this. Otherwise, I'll wait a bit until you guys install Node. code open, and not a lot of people. Much better version of Replit code has. Let's kick things off with some properties of JavaScript. Before we write any code, some high-level properties, questions that might be asked. Every language comes with its unique set of features. There's always a question as to should you use JavaScript or should you use C or should you use C++ or should you use Golang. Let's talk about the features of JavaScript. The first one is JavaScript is an interpreted language. अब ये बहुत random term I'm throwing at you. Interpreted language, or more technically it's called just-in-time compilation object language. But this means it is executed line by line at runtime by the JavaScript engine in the browser or in the server environment. This is a slightly complicated term to digest, but let's go through it again. JavaScript is an interpreted language. Now there are two high-level types of languages: compiled languages or interpreted languages. C++, Rust, Golang are compiled languages. Python, JavaScript are high-level, but there are some differences between them, but generally they're interpreted languages. What does that mean? That means when you want to run a C++ file, you first convert this file to a binary, which means a file that you and I can't read, like it has a bunch of zeros and ones. It ends with .exe, let's say, and then that .exe file you run. So there's a lot of checks that happen in this step of compiling your C++ code, converting your high-level C++ code that you've written into something that the browser can, or the machine or the CPU can understand. There is a compilation step. If you have written C++ code, you might remember that after you write your C++ code, the first thing you do is you run this g++a.cpp-o out. You run this command to convert your CPP file to a binary file. You can write out or out.exe, whatever you want to write, and then you actually run the ./out binary. In my case, there's no a.cpp file, which basically means let me open here. This is a JavaScript file. Let me also create a code. Compile this code into a binary. So I will open my terminal. I will run this command g++ main.cpp-o out. I have to probably include something here. I forgot if the device not rich, but not enough. Which one is, guys, how do you import C out? Where does it come from? And for some here, livestream, thank you. Livestream. Here's me writing some C++ code. Here's me compiling that C++ code. This command, compile my C++ code. Here is me running that C++ code. The C++ code when I ran, it outputted something called hi there. You might ask here, आपने क्या C++ program लिखा? You might ask here, what is this C++ program? It is a program that when you run, it prints hi there on the screen. These are called hello world programs. The first program you should write. If you ever learn a new language, it is a futile and useless program like But in the end, what is the game? A game is basically when you run the game, you see a bunch of visuals, right? Now those visuals are small pixels, people output it there on the screen. It's not the big two things. These are time. ये code run होना शुरू हो जाता है empty line and time, which means at that point, this automatic assembly and actually ran on the compiler just in time compilation compared to the very file compiles once and then runs once. Which one is better? Which one is worse? Why would you choose this over this? There are pros and cons to both of them. We'll read through them very soon. The pros are there is one less step to do before running your code. आपको दो चीजें करने की जरूरत नहीं है. You don't have to first run command number 1, then run command number 2. If you're quickly debugging, writing code again and again, you run a command, it runs. You run a command, it runs. Versus compiling C++ code takes as you saw, some time. It took like 300 milliseconds, 400 milliseconds. Versus JavaScript immediately runs. But does it? When I'm running JavaScript, it is also slowly compiling, right? It is just compiling line by line. This is compiling once and for all. So it's not necessary कि इसका compilation step is making you slow. It's just doing it पहले. JavaScript is doing it one after the other. But there are some downsides of JavaScript. Upside is as a developer very easy to run. Downsides are number 1, performance overhead. In case of C++, you pass this node application minute, which and you might think about JavaScript is it is dynamically typed. It is dynamically typed, which basically means there is no concept of types in JavaScript. I repeat. Types क्या होते हैं we will have to understand first. But if you look at this C++ code that is written on the screen, if you've done C++, hopefully you understand it. If you have not done, what are the top of now use that from stated variable I boolean change to a string boolean true and this should do no index.js. It does run. It prints true on the screen, which is what this should do because a variable is assigned the value 1. It's changed to a string, changed to a boolean, and then the final value that it stores is the boolean. What is a boolean? True or false. That is what a boolean is. Something that takes only one of two values, true or false, is what a boolean is. The C++ program won't equal because you can change one variable type throughout it. High level pay. Your machine that you might term single threaded and it involves another term which is related to operating systems. High level pay. Your machine that you might have bought. For example, I have a Mac machine and my Mac machine has, let's say, 9 CPUs. CPU number 1, CPU number 2, so on and so forth. When you buy a machine, you decide or you pay based on the number of CPUs you're using. If you have a lot of CPU, one program. What does it mean to run a program? This, when I run node index.js, when I run ./out, it is running on one of these CPUs. अगर ये सारे occupied होते, if I'm running thousands of things on my Mac, if all of the CPUs are occupied, then if I run this, it will not run क्योंकि इसको CPU ही नहीं मिलेगा जाने को. That is the job.
job of the operating system. If there are 100 applications running on a machine, for example, I have OBS, Zoom, VS Code, Postman, Brave, a lot of these applications open, let's say 100 applications. Every application gets some time on some CPUs. Zoom might be, spending 10% of the time on this CPU, 20% of the time on this machine. GTS, there might be another one that, let's say I started to play GTA 20% of the time on this CPU. There might be another one that, let's say I started to play GTA on this machine, GTA 6. Then 1, 2, 3, 4, 5, 6. All 6 CPUs might just be running GTA. So it depends on the kind of program you have written. And if you really want to see कौन कितना CPU use कर रहा है, there is this utility called htop that I don't have on my machine, but I should add because it's a new Mac. But if you run top, it will tell you what process, for example, in my case, Zoom is using 35% of one of the CPUs. Windows Server, which I don't know what this is, I should probably stop it, is using 51% of one CPU. मतलब one of these CPUs का आधा is being used by this specific process. OBS, when I'm recording, is using 26% of the CPU on one of these CPUs, 26% of one of these CPUs. That changes. कि कभी-कभी यहाँ पे run होगा, कभी यहाँ single threaded. Now, what is a thread is a whole different discussion that we can get to later. But एक term होती है single threaded और multi threaded. JavaScript, single threaded. Rust, C++, Java, Golang, multi threaded. Rust, C++, Java, Golang, multi threaded. JavaScript, PHP, single threaded. This is one of the downsides of these languages. कि अगर आपके पास बहुत बड़ी machine भी है, if I have a very big machine also, for example, my Mac is a 9 CPU machine, if I run some extremely expensive, CPU task on it, जैसे find the sum from 1 to 20 million or find the sum from 1 to 100 million, so unfortunately, JavaScript will only be able to occupy one CPU, irrespective of how big the machine is. But if I write my code in Golang, C++, or Rust, and I write it the right way, I repeat, I write my code सही तरीके से in the right way, then I can actually do this 9 times faster. This arithmetic of finding the sum from 1 to very big number, let's say, I can do this arithmetic very fast compared to JavaScript if I am writing multi-threaded code in Rust, C++, Go. That is why you might want to prefer these languages over these. We'll probably do some discussion and Rust code. There is a slide that I can point you to as well. It's probably not here, but I will point you to it in a second. There you go. Here is a nice comparison between three languages. Node.js and Bun.js are both JavaScript, but they're different interpreters, Golang and Rust. Try to go through these slides. If you want, इसकी एक video है that I can also post as an offline video or recorded video, where you'll actually see the performance differences between these languages. So JavaScript is not the best language, long story short, for running a bunch of these things, or you're running any backend application. It shouldn't be your first choice. A lot of times it is your first choice because it's just very easy to write JavaScript code compared to other languages. Lastly, there's another concept of garbage collection, which is related to something called memory management. High level, as you see over here, I am writing a bunch of these variables. अभी मैंने एक A variable बनाया है. I might write 20 variables and 100 variables, 1000 variables, 10,000 variables. All of these variables are taking up some space on my random access memory, the RAM of my machine. From time to time, these need to be cleared from the RAM. अगर इस A variable की जरूरत नहीं है beyond a point, during the execution of the program, if the A variable is not needed, it should be removed from the RAM so that the RAM becomes empty for other programs. That is done through different ways on different languages. In case of JavaScript, it's done through a garbage collector, and garbage collectors are generally slow in C++. And there's a very specific Rust way that again we can get to when we teach Rust in Solana. But this is again one of the downsides I would say. The garbage collector does make JavaScript and Java slow compared to Rust, which does not have a garbage collector, and compared to C++, which also doesn't have a garbage collector. But here a lot of the onus of memory management is on you. Here the onus of memory management is on the Rust compiler. I've said a lot of things here. For example, memory management, but memory management basically means आपके RAM and where in memory is generally slow. Conclusion: is JavaScript a good language? Yes and no. It is a beginner-friendly language. It has a lot of performance overhead. Compilation नहीं है, just-in-time compilation है, interpreted language है. It is generally a lot of this by making it faster. JavaScript fast. If you have properties of JavaScript, it's written by early developers, easy to hide. Its algorithm script credit goes to $10. Bun is trying to solve a lot of this. This is the slide aged well. Last year I said Bun is trying to solve all of this. I was very bullish on them also, and they got acquired by Anthropic for $250 million. One company that tried to make JavaScript better by making it faster. TypeScript is a very heavily used language in Bun, but TypeScript credit goes to Microsoft. Microsoft created TypeScript, but Bun created a faster compiler for JavaScript, faster runtime for JavaScript. And there were a lot of efforts at least until last year to make a better JavaScript runtime. What is a JavaScript runtime? We will come to. But generally, if you have the choice and if you're building the most optimal trading algorithm, you will not write it in JavaScript. You will write it in C, C++, Rust, or Zig, or Go maybe. Alright, these were the properties of JavaScript. Conclusion was it is not the best language maybe. Why is it still used? Because unfortunately most software today is written in either JavaScript or PHP. Unfortunately, these are the two popular languages. These are easy to understand. Most software is written by early developers, easy to hire. Java, JavaScript, JavaScript, maybe Go, and then PHP are the primary languages in which most software is written, which is why you learn these languages. Alright, we kick things off with the syntax of JavaScript. Syntax का मतलब क्या होता है? What do you write and what does it achieve? Hopefully you've done this in the DSA classes. What code do I write to achieve something? अंत में, what do I want to do? Using JavaScript, I want to make a website like ChatGPT. Using JavaScript, I want to make a website like LangGraph. Using JavaScript, I want to make a website like Golang. उसके लिए you will have to write some code. The code that you write, उसके building blocks are known as the syntax of a language. I repeat, this is known as the syntax of a language. The first thing that every language has, not just JavaScript, is this concept of variables. The name itself is giving away what a variable would be. Variables are used to store data. If you are making something like google.com, you are going to write a search query here. You will search for for, how tall is Hakirat, that thing, that string is called a variable because it is changing. I can type anything random over here. Whatever I write is stored in a variable. These are what? वेरिएबल्स आई वेबसाइट को बनाने के लिए यू क्रिएट मेनी वेरिएबल्स द वे टू क्रिएट अ वेरिएबल इज using 3 different syntaxes in JavaScript. The first is the simplest and the oldest one, variable something equal to something. For example,
so basically is function scope and note and block scope mistake. Fine.
यहाँ पे हमने क्या लिखा था थोड़ी देर पहले, what did we write? Variable a equal to 1. And then I changed the type of this variable and the value of this variable to something else, something else. How do you do it in C++? This is simply write either variable a equal to 1 or let a equal to 1 or let's say 2013, 2014. उसके बाद there were two new types or two new ways to create variables, let and const, which are generally the ways you use today. In any code base that you look at, you will rarely, if at all, ever see this syntax. It is the older way. It is not used anymore. There are a bunch of downsides, and it's a very popular question. Okay, should you use where? Should you use let? Should you use const? What is the difference between the three? Answer is you should use let and const. If there is a variable that is going to change through the life cycle of the project, then you write let variable name equal to something. If there is a variable जिसकी value आपको पता है change नहीं होगी, whose value is not going to change through the program. If there is a variable whose value is going to change, it should be defined as a let. You should almost never use variables or where. First assignment: create a variable for each of the following: your favorite color, your height in centimeters, and whether you like. So, what is the second thing? My centimeter, so my height.
Types. That's in JS. We have number, we have boolean, we have strings. Null, undefined, while for complex type of we have green objects.
If you're writing so they can just do the assignment. I will open WhatsApp. Hopefully everything is off screen. Well, how many that you got? All right. In JavaScript, concept exists everywhere, not just in JavaScript. It exists in C++, Golang, every other language. Data types. There are 4 common data types that you would use already. In which these variables, this is a very common statement in most programs. Why they become useful? Why do you need a variable? If you've done DSA, you already know. If you have not done DSA, then you have to bear with me for a little bit before we write some code, and then you'll understand the importance of variables. Data types, 3 types of data types. There's one more complex type called arrays, but we will get to arrays in a bit. Before that, we move to operators. There are many operators. The simpler ones are the arithmetic operators in any language. They exist. They look the same in every language. You can add two variables. You can subtract them, multiply them, divide them. There is the is equal to operator that is used in if statements. Once we reach if else statements, you'll understand it. There are logical operators like this. For example, a double AND would be अगर ये और ये दोनों true है, then it will resolve to true. If either one of them is false, it will resolve to false. If both of them are false, it will resolve to false. And then there's this concept of functions. पहले मैं यहाँ तक एक बार hold कर लेता हूँ कि ये एकदम simple है ना. Like I'm hoping all of you have done this in the warm-up classes. I suddenly realized all of this was already shared. So very simple. Are you good to go? Yes. It's like table stakes. Very simple. All right. 95% understand. Great number. Operators stuck. Hopefully, as you write code, you understand it more. But functions become the first slightly more complicated part. If you have not done them before, functions are used to group logic together. I repeat, अगर आपका कोई logic है, मान लो कुछ arithmetic है, it was unless hello you give it. But what if first needs to be and I am violating a rule of computer science here. The code is not you can accept plus the writing a function and encapsulating the repeat increase. If you have 100 such calls or 1,000 such calls, then writing three the argument that is you are not allowed to vote. How do you write this code? We know how to create variables. We based on a condition do different things. If age is the code exist program run hoga here call so the if statement will say control I repeat then equal to 0 matlab it increases the value of I. So this specific for loop, if I remove all of 339, because I want to write this logic up until 100, and I want to increase this number by 1 in every iteration. Every time the for loop runs, it is called an iteration. I want to run this once every iteration. Should I write it after a tab or should I write it shuru mein? I should write it after a tab. Whenever curly braces start, you should write the code after a tab. This is called indentation. In every iteration of this, I want to call is legal with that specific I. In the first iteration, I want to call it with 1. In the second iteration, I want to call it with 2. In the third iteration, I want to call it with 3. So on and so forth. So if I run this code, what do you think it will print? It will print you are not allowed to vote 18 times for age 1 to 18, 1 to 17, actually 17 times. And then it will print you are allowed to vote for the rest, whatever.
Social declaration.
82 times, I think, 83 times. If I run this, सबसे पहले it says you are not allowed to vote for a few ages. Then it says you are allowed to find functions. You have functions, variables, conditional statements, and loops. Do we understand this? Yes or no? The answer is yes. We move concepts exist in every language, including objects and arrays. There are two things we are learning in this slide: objects and arrays. Both of these exist in every language. They are called different things in different languages. In Rust, objects are called hash maps. In Java, objects are called hash maps. Generally, there is a generic term for them called key value stores. I repeat, there is a term called key value stores. They are called objects. An object in JavaScript is a collection of any JavaScript data type, like strings, numbers, or it can be another object. Let's understand this with an example. Let's say I want to store multiple things about Hakirat somewhere. You might have someone who signs up on your website. When they sign up, let's understand this with an example. Let's say I want to store multiple things about like strings, numbers, or it can be another object. Let's understand this with an example. Let's say I want to store multiple things about Hakirat somewhere. You might have someone who signs, but if you that allow okay, for the same one का name है. What did I have to pass to the is legal variable function? Sorry, key called function state address. Sorry, have yes. For anyone who's waiting for async.js, I don't think it's happening today. It's already past 1 hour. The only other thing we will learn today would be, how do you know that slide? You know what, we'll probably finish here and we'll probably do some assignments. We'll do Q&A, we'll call it. I don't think we're going to learn the rest of this today. We'll probably learn this in the next class. Yeah, we'll probably learn everything from synchronous, asynchronous code. So if you're waiting for all of this, I would say, yeah, I don't think you'll have the attention for 3 hours to continue through all of this. So feel free to call it if you were waiting for all of this. For everyone else, let's do some practice and ensure we totally understand complex types well. 92% is decentish. There are some assignments to do. You should do those assignments. We'll practice this a little bit more after the last lecture. Now, we are sticking at more at 0. A better way though. Great. Let's set this equal to 0. 2 I less than and 3. You can have an array of strings. Have come to string full object. If I want to object name, we get this for the individual of piston in case of flip cards. Object also for now has object or is obviously or the function. What which iterate dynamic based on I will find put this subset so function different. These are for an MPI. You do them yourself. Do we understand objects and arrays? 95% is beautiful. You will receive a bunch of practice questions. You should do them. Next week, we're going to understand what are callback. Next questions that you might have. Right. Please, was the question? Please explain how to write off this Hawaii for you to watch, and then we can move on to prompts. Covering these slides that I'm happy to share. So let me do a poll. Could be up on Twitter or something like that. How do you this time? Was it? It will be called something else, but basically the Super30 warming up video where you'll find it. The JavaScript event loop again comes next week. That's going to be the last slide for next week. Or if you want, we'll do a poll. I'll do a poll. If you guys want it to be offline, then I'm sure there's a video that I can find where I've covered all of this. And just post that video for you to watch, and then we can move on to promises next week. I'll do a poll based on that. You will decide. Yeah, I'm happy to do a recorded lecture. So, I mean, there is probably a recording lecture covering these slides that I'm happy to share. So let me do a poll. If everyone says record is good, then I will cover all of this in a recorded session. There's no backlog if you join the course today. It's just one class, so finish it up quick and then do your thing. Right. List of all the Notion assignments with direct links. Yes, it will all be up on projects.100xstars.com soon enough. A cohort for a Bootcamp 1.0 section there where you'll find all the assignments. I'm trying my best to get it by next week. Along with links on app100xstars.com. That'll be very easy. No advice yet for the 15th Feb hackathon. Go to the Solana classes. That's what I'll say. Some cryptography things like these. I'm doing project for my company in which I want some network data router based on something and volunteer binary to get basic network data when I implement web correction Rust to stream data to my backend. There might be a lot of resources for it. I don't have any video on this on YouTube, but I do have a video on this on in Super30. There is a video in Super30 where we've covered how to do WebSockets in Rust, which seems like exactly what you need. So somehow ask Mikey to give you access to that specific video. How do you end a super team? Super devs is coming next month. We're announcing it, I think, end of Feb-ish. That's the easiest way to get into Super Team. And this time, was it'll be called something else, but basically the Super Devs, hack or whatever cohort, call it, we did last time, is coming again as the Solana Bootcamp. I think we'll see what to name it. But if you get into that, then it should be easy to get into Super Team. Basically, the top people from there should get into Super Team easily. All right. I think that's all the questions. Simple enough class. Hopefully, very simple stuff for most people. I would suggest you practice a lot. Prash will share the assignments. Please do the assignments. And because the next 2 weeks are basically really hard. Once Express starts, things are easy. But I know this because 3 cohorts and then school, we've seen this many times. The most confusing bit is coming, which is asynchronous JavaScript and promises. So if you're not up to speed up until this point, that will become really hard. So try to tests for assignment, course and assignment will be posted by Mikey. Mikey ask Rahul. Rahul give you the tests, post them on Discord, so you guys can try and let me know how many points you got. I can tell you the Super30 scores, like somewhere in Discord only. How much I think the highest was 65 or something. Same guy wins every time. Siddhant, this time he got 65. If you got 65 or above, that's really good. If you got 30 or above, that's not bad. If you got 10 or if you got less than 30, basically not great. All right, we call it here. Thank you, everyone. We see you tomorrow in the blockchain class. We'll understand private keys and creating our first wallet, web-based wallet, fairly simple stuff. Hopefully, should be a simple class tomorrow as well. A lot of what we've done today is a prerequisite for tomorrow, so I hope you have some JavaScript basics done before you join tomorrow's class. With that, I will end it. See you guys tomorrow at 8:30 p.m. Bye bye.
In this video, we need to go back to value types. So types are one of the fundamental aspects in programming, and converting between types is something that we do in every programming language. For example, converting a string to a number, it's important that we learn about this before being able to move on further in the course. That's especially true for a language like JavaScript, which sometimes behaves in a weird way, as we will see in this video. Now, in JavaScript, there's type conversion and type coercion. So they sound very similar, but are different. So type conversion is when we manually convert. JavaScript automatically converts types behind the scenes for us. So that's necessary in some situation, but it happens implicitly, completely hidden from us. Okay? So let's start with type conversion, which remember is when we explicitly want to convert from one type to another. So let's say that we have an input field on a web page for the user to input their birth year. And these inputs from input fields usually come as strings. So let's say that the input year that we get from the user interface is a string with the value 1991. But now if we want to do some calculations with this won't really work. So let me show that to you. So console.log, let's say input year, and now plus 18. And so like this, we can calculate in what year the person will become of full age. Now, remember that when we have a string and add something to the string, it will basically concatenate the strings. So we can't expect that this actually adds 18 to this number here, because it's a string. So let me show you the contains of converting this string. So we can mix numbers, but just get confused by that. And so indeed, now we get 1991 here in this pink color, basically. And the colors might change throughout the time. By the time I record this video, numbers are pink, and strings are just this white. Let me actually print them both. And so that should make it really string. A number actually means invalid number. It's not really not a number. And let me actually prove that to you. So we can check the type of n, a, n, so not a number. And as you will see, the weird result of this is that the type of not a number is actually number. And so again, not a number actually means an invalid number. It's still a number somehow, but it's an invalid one. So again, we get not a number whenever an operation involving numbers fails to give us a new number. Okay, so that is converting strings to numbers, but of course we can also do the opposite. It's a little bit less important, I would say, but I still want to show it to you. So to do it, the other way around, we use this string function, and that's quite straightforward, right? Just keep in mind that we need to really start it with a capital S, just like here the number function needs to start with a capital N. Otherwise, it's not going to work. So we get 23. And remember that whenever the value here is white, then it means it is a string. So it looks kind of the same. Let's again block both just to make this point. So the pink one is the value that actually has the number type, and this one has the string type. Okay, so again, this one is not as important. 2, 3 types. So we can convert and not, for example, of sense. Now here we only converted two numbers in a special way. And for that reason, there is a separate lecture coming up. So that is type conversion, where we do manually convert from one type to another. However, in practice, we rarely have to do it manually, because JavaScript actually does type coercion automatically for us in many situations. So let's talk about it now. And let's just separate it here with some comments. So type conversion, type coercion, dealing with two valid scenes, convert one of the vectors. And actually, we already saw that happening. If you throw that here, I am plus years old, 3 years. So others. JavaScript, the plus operator that we used here, triggers a coercion to store will be converted to as. And the same actually happens in template literals. It also takes all the number values and also converts them to strings. Now, then we would have to manually do this like we just learned before. Then we would have to do string 23, and then this would be the only way that this would work. But luckily for us, JavaScript has type coercion, and so this will happen completely automatically behind the scenes. Now, actually, not all the operators do type coercion to string. So let me show you something else. So if we do, two numbers are converted to numbers and not the other way around, are concatenated. Okay, so this is a very important distinction to keep in mind, because this actually confuses many JavaScript beginners when they don't know about this. So let's try another one here, and I'm again using 23 the string times 2 the string. And again, you will see that these values are going to be converted to numbers before. And indeed, that's why we get 46. But the multiplier. Okay, so I hope that the distinction between type conversion and type, we got it. Let's play a game called Guess the to Guess One. So essentially, we start with 1 the string, then we add 1, and then we subtract 1. So take a moment to think what this should look like, and then let's take a look at the solution. So we talked about type conversion and coercion to numbers and to strings, but I didn't mention booleans yet, right? That's because we need to learn the concept of truthy and falsy values first, and so that's what we're going to do now. So let's get right into it. So falsy values are values that are not exactly false, but will become false when we try to convert them into a boolean. And in JavaScript, there are only 5 falsy values. And let me actually write them down here for you. So 5 falsy values. And they are 0, the empty string, undefined, null, and not a number. And that's it. Of course, false itself is already false, so we don't need to include it in the list of falsy values. So again, all of these 5 values will be converted to false when we attempt to convert them to a Boolean. They're not exactly false initially, but they will become when converted to a Boolean. So that's the definition of falsy values. Everything else are so-called truthy values, so values that will be converted to true. For example, any number that is not 0 or any string that is not an empty string will be converted to true when we attempt to convert them to a Boolean. And so let's actually see that in practice function, a falsy value for some different, and it's not an empty, and we will learn about. So and we see that indeed converting the 0 for undefined, it's also false. But then any string that is not an empty object here, it's also, well, false. Again, because so that's what truthy and falsy values are, and this is how we could convert them to Booleans. But in practice, I actually never did this in my life. I never used this function here in practice. This was just to show you the concept of truthy and falsy values. So in practice, the conversion to Boolean is always implicit, not explicit. Or in other words, is always type coercion that JavaScript does automatically behind the scenes. But when exactly does JavaScript do type coercion to Booleans? Well, it happens in 2 scenarios. First, when using logical operators, and second, in a logical context, like for example in the condition of an if-else statement. And we're going to talk about logical operators in a future lecture, so let's now go back to the if-else statement and see how type coercion works in the if-else condition. So let's say that we have a money variable. And in the beginning, we don't have any money. So far, we have only used comparison operators to take decisions with if-else statements, right? But let's suppose we want to check if 2 values are actually equal, instead of one being greater or less than the other. And for that, we have different equality operators. So let's start again with an h variable and set it equal to 18. And I'm using h all the time because it's so easy to make simple calculations with it. So let's now create an if statement which will log to the console that the person just became an adult only if the age is exactly 18. So we can use an if statement, as you already know. And now to check if the age is exactly 18, we use the triple equal. Okay, and that's it. Let's now write the block of this if statement and then execute it, and then I'll explain what happened here a little bit better. Now, whenever our if block only has one line, we actually don't need the curly braces. Okay, so we don't need to create this block if we only have one line. So we can omit this and only write this one line of code. In this case, you just became an adult. So let's test this. And indeed, the result is that we see the string locked to the console. And if the value would be something else, for example 19, then age is no longer equal to 18, and so we shouldn't see this result. And then indeed. But let's put it back to 18. Okay, so how does this equality operator here actually work? Well, just like the comparison operators, this operator will return a true or a false value, so a Boolean value. Only that in this case, true will only be the result of this operator in case that both sides are exactly the same. Alright, let's actually show that result to you. And actually we can do that right here in the console. So if I say 18 equal to 18, this will be true. But if I say 18 equal to 19, it will be false. And so that's exactly what we used here as a condition in this if block. So don't confuse the assignment, which is just a single equal, with the comparison operator, which is this triple equal. Now, besides this triple equal, we also have a double equal. So the difference is that this one here with the 3 equals is called the strict equality operator. It's strict because it does not perform type coercion, and so it only returns true when both values are exactly the same. On the other hand, there's also the loose equality operator, which is only 2 equals, and the loose equality operator actually does type coercion. So let's see that here in the console again. So in this case, I can do 18, the string, equal 18, the number, and it will still give me true. So again, the double equal does type coercion. So what this means is that this string here, this 18, will be converted to a number, and then the number 18 is the same as this number 18. Now, as I mentioned, the triple equal does not perform type coercion, and so let me show that to you. And so it's false, because 18 the string is of course different than 18 the number. So it's not the same, and JavaScript does not convert them for us. So let's try that also here in our code. And I'm just going to copy this one, and then this, and let's say here lose, and here strict. So if I run this now, both these conditions should be true. So 18 the number, which is the age right now, is equal to this 18 the number, right? It's strictly equal, but it's also loosely equal. So 18 the number is of course also loosely equal to this 18. So let's run that, and indeed we get the strict and the loose string printed to the console. But now if we change this to 18 the string, well, what do we expect to happen then? And indeed, only this line of code here is executed. So this one which says loose here, as we see here. And so that's because of the result that I showed you earlier, which is that with the loose equality operator, 18 the string is the same as 18 the number, because 18 the string will be converted to 18 the number. So I hope that's not too confusing for you. It is actually quite a confusing topic in JavaScript, because this loose equality operator, so this one here, is full of really weird rules and behaviors. This means that if we use this one here, this can introduce many hard-to-find bugs into our code. So as a general rule for clean code, avoid the loose equality operator as much as you can. So when comparing values, always use strict equality with the 3 equal signs, as I showed you here. And that's the reason why I showed you this one first. This is something that actually most JavaScript developers advise you to do, so it's a good rule for sure, even if we actually need type conversion. In that case, it's better to convert the value manually, always default to the triple equal operator, and pre-type it to you. But from now on, we will assume that it doesn't even exist. Great, so let's do another example here, because I actually have some more great stuff to show you. And the first thing that I want to show you is that there is a pretty simple way of getting a value from any web page. We can do that by using the prompt function. And again, we will learn what functions are in the next section, but this is how it works. So we just write for his favorite number. No, so we get just input it. But we need to store this value somewhere, so let's create a. Let's learn about the switch statement, which is an alternative way of writing a complicated if-else statement when all we want to do is to compare one value to multiple different options, basically. So in this example, let's say we have a weekday variable. Okay, but it doesn't. Errors, and again the same error. And you see that we're writing quite a lot of repetitive code, especially. third day, right? So whenever the day it's fixed and it works, it's just fine. Okay, great. That's how the switch statement works. And remember that now that we're getting more comfortable with JavaScript, it's time to learn about a more theoretical concept. And that's the difference between statements and expressions. And this is going to be just a very high-level overview, just so that the future lectures make more sense. So essentially, an expression is a piece of code that produces a value. For example, 3 plus 4 is an expression, because this is going to produce a value. Okay? So I don't even mean the entire line of code. What I mean is really just this 3 plus 4. This is an expression. Okay? And again, because it does produce a value. The same goes, for example, for just any number. This, for example, is an expression too, even though it's just a simple value. But it's still also an expression, because again, this itself will produce a value in JavaScript. Or we can do this. So true and false and not false. So all of this here is an expression, right? Because this will in the end produce some Boolean value. Now on the other hand, we have statements. And a statement is like a bigger piece of code that is executed and which does not produce a value on itself. And we can compare this with normal spoken language. And so in this example, a declaration is like a complete sentence, and expressions are like the words that make up the sentences. Now basically, we write our whole programs as a sequence of actions. And these actions are statements. So let's take as an example the if-else statement. So let's say if 23 is greater than 10, then well, just do something. So create a string called 23 is bigger. The code itself doesn't really matter here. So this if-else statement is in fact a statement. And so that's the reason why I have called it the if-else statement all the time. And the same is true for the switch statement. So this statement here doesn't really produce a value, does it? All it does is, in this case, it simply declares this variable called str. But that's it. It performs some actions, in this case declaring this variable, but it doesn't produce a value. And so in that, it's different from, for example, having this here. Okay? Now the string itself, again, is an expression. So this is probably a bit confusing, but that's not a problem, okay? My goal here is not that you understand the exact rules of what an expression is and what a statement is, because in fact, it's all a bit fuzzy. So my main goal with this lecture is really that you know that statements and expressions exist, and that expressions produce values, and that statements are like full sentences that translate our actions. So the actions that we want the program to perform, okay? So really, that's all you need to know, and all you need to basically memorize from this video. We don't need to go into all the details. So there's no need to start asking a bunch of questions about this in the Q&A section, all right? So this will all make even more sense as we move on. So I said that this string here is itself an expression, and then this whole line of code is a statement, because this again does not produce a value. And so basically, whenever something ends with a semicolon, that's then a statement. It's like a complete sentence, okay? Now this difference between expressions and statements is important to know, because JavaScript expects statements and expressions in different places. For example, in a template literal, we can only insert expressions, but not statements. So let me just very quickly demonstrate that to you. So we can say, I'm, and then our placeholder here, basically. And so in here, we need to put an expression. So something that produces a value, which can then be put into the string that we're building here using the template literal. So let's say, just to do some calculations here, so 2037 minus 1991 years old. So again, this is an expression here. And so this one will work. However, we cannot do this. For example, we cannot insert this if statement in here. It wouldn't make any sense at all. Okay, let's try that. And so we actually get right away unexpected token if. And that's because JavaScript knows that this is a statement, and statements don't make sense where JavaScript expects an expression. Now if we had a variable, for example, then if we used that here, then this would actually also be an expression, because this variable will essentially just be replaced with this string. And so this produces a value, and so of course, this is completely acceptable. Okay? And that's actually all I had to show you in this video. Again, my goal was really just to make sure that you kind of understand the difference between expressions and declarations, so that moving forward, we are really both on the same page here. So we all already saw two ways of writing conditionals. Or else, drink2 is going to be this water here. Okay, and again, we need to define the drink2 variable outside of the if and the else blocks, because any variable that we define inside of a block, for example, when we have bigger blocks of code that we need to execute based on a condition, in that case, the ternary operator is not going to work. But the ternary operator is perfect when we just need to take a quick decision, for example, like this. Now that you're familiar with the fundamentals of the JavaScript language, we need to talk about JavaScript releases or versions before moving on. And we briefly talked about this in the intro video, but now let's go into more depth, because it's really important to know about how JavaScript releases work and how we can use them. It's important for your work as a web developer, and also because you will see these topics coming up in the developer community all the time, and so you want to be able to understand what's going on. And the best way to start understanding JavaScript versions is by looking at the history of JavaScript. So let's do that. And let's start at the beginning of the internet itself.
So quickly after the internet was invented and the first web browsers were developed, developers wanted to start making websites more interactive. In other words, they needed a programming language for the browser. So in 1995, the Netscape Navigator, which by the time was the dominant browser, hired a guy named Brendan Eich to create the very first version of JavaScript in just 10 days. It was called Mocha, so not JavaScript yet, but it already had many of the fundamental features that modern JavaScript has today. So that's very impressive that he basically created this first version in really just 10 days. Then in 1996, Mocha was renamed to LiveScript, which was then again renamed to JavaScript for one simple reason: to attract developers from the hottest language at the time, which was Java. So the Java in JavaScript was really just for marketing reasons, because the language itself has basically nothing to do with Java. Now some beginners think that this is the case, but actually no. JavaScript and Java are two completely different languages. Also in 1996, Microsoft launched the Internet Explorer, which basically copied JavaScript from Netscape, but they called it JScript for legal reasons, because, well, you actually cannot just go around and copy other people's programming languages. Now, what this means is that we now had two very similar but competing languages, which of course is never a good idea in the long run. And so, with the internet growing like crazy around this time, people realized they needed to standardize JavaScript. So the language was submitted to an independent standard organization called ECMA, which in 1997 released ECMAScript 1, or ES1. This was the very first official standard for the JavaScript language, and with this, every browser could now implement the same standard JavaScript. In the real world, we usually use the term ECMAScript to refer to the standard, while JavaScript is used when we talk about the language in practice, as it's implemented in browsers. Now, fast forward to 2009, after a lot of complications and disagreements about where the language should be headed, ES5 was released with a lot of great new features. And then finally, another 6 years later, the much-awaited new version ES6 was launched in June 2015. And this was the single biggest update to the language ever. So it contained a ton of new exciting features, which we will explore throughout this entire course. This was, and still is, a really big deal for JavaScript and for the whole web developer community. Now, you will also see ES6 being called ES 2015, which is actually the official name, but most people just call it ES6, and so that's what I'm going to do here as well. And actually the reason for ES6 being called ES 2015 officially is that in 2015, ECMAScript changed to an annual release cycle. So right now, there's going to be a new release every single year. The reason for that is that they prefer to just add a small number of new features per year instead of shipping a huge new version every couple of years like it happened with ES6. And so this way, it's going to be much easier for everyone to keep up to date. And so according to this new annual release cycle, in 2016, ES 2016, or ES7 was released, ES 2017 in 2017, and like this, it will continue until the end of time, or something like that. Now, there's one particularity about JavaScript releases which is pretty unique for any programming language, and that is backwards compatibility all the way to ES1. So what does that actually mean? Well, basically it means that if you were to take some JavaScript code written back in 1997 and put it in a modern browser with a modern JavaScript engine today, it would still work just the same. So again, the JavaScript engine that's in our browser today is able to understand old code written 25 years ago without having to rely on version numbers or anything like that. It just works. And it works this way because of the fundamental principle that's baked into the JavaScript language and its development, which is to not break the web. This means that there's almost never anything removed from the language, but only added in new versions. And actually, we cannot really call them new versions even, because they do not contain breaking changes like when other languages move to a new version. Instead, new versions are always just incremental updates which add new stuff, and so I like to call them releases and not versions. The ECMAScript committee who works on updating the language does all this so that all websites basically keep working forever. Just imagine they removed some important feature that made a website from 2008 work just fine. If you then wanted to visit that page, it would be broken. And that's why we, fortunately, have the don't break the web principle. Now, of course, this comes with problems, because there are tons of old bugs and weird things in the language. Remember that Brendan Eich made the very first version in just 10 days, and no one back then could even imagine what JavaScript would be used for one day. The initial goal of JavaScript was just to add some simple dynamics to pages, not to write whole web applications in the browser like we do today. But anyway, these bugs and weird quirks in the language have been giving the language a bad reputation among many programmers, who can't really take JavaScript serious because of this. But here's the thing, we can actually go around many of this weird stuff by simply learning the modern JavaScript that matters today and just ignore most of the old weird stuff. And so that's exactly what we're going to do in this course. So next time your friends start hating on JavaScript, and believe me, this actually happens, then just tell them about the amazing things that you can build with it. Okay, but now there is one more thing that we need to talk about here, and that is forwards compatibility. So what do you think would happen if we took this totally made up code from the year 2089 and tried to run it in today's browsers? Well, you're probably right, it would not work at all. There would be errors left and right, and nothing would work. That's why we say that JavaScript is not forwards compatible, basically because current browsers do not understand code from the future. And this actually brings us to our next. What would happen if we took this totally made up code from the year 2089 and tried to run it in today's browsers? Well, you're probably right, it would not work at all. There would be errors left and right, and nothing would work. That's why we say that JavaScript is not forwards compatible, basically because current browsers do not understand code from the future. And this actually brings us to our next topic, which is how can we use modern JavaScript today? Because browsers that users are using might be old, and there's no forwards compatibility, right? So to answer the question how we can use modern JavaScript today, we need to consider two distinct scenarios, development and production. So the development phase is simply when you're building the site or application on your computer. To ensure you can use the latest JavaScript features in this phase, all you have to do is to use the most up-to-date version of the Google Chrome browser. This will then ensure that all the features I show you in this course will work for you as well. The second scenario is production, which is when your web application is finished, you deploy it on the internet, and it's then running in your users' browsers. And this is where problems might appear, because this is the part that we actually can't control. We cannot control which browser the user uses, and we also can't assume that all our users always use the latest browsers, right? Now the solution to this problem is to basically convert these modern JavaScript versions back to ES5 using a process called transpiling and also polyfilling. We will use a tool called Babel later in the course to transpile our code, but for now, during the course, we won't need that. Again, because you're using the most up-to-date browser during development. Transpiling back to ES5 is only necessary after your app is developed and you want to ship it to your users. Alright, so now let's take a look at how different JavaScript releases can be used today. So first off, ES5 is of course fully supported in all browsers today, all the way down to Internet Explorer 9 from 2011. So we can assume that ES5 is safe to be used at this point, which is the reason why we use it as a target for transpiling. Now, about the newer releases, ES6, ES7, and all the way to ES 2020, as of mid-2020, they are actually quite well supported already in all modern browsers. And we usually call all the current versions together ES6 Plus. So right now, that's from ES6 to ES 2020, and basically, altogether, they are the modern JavaScript. Now, it's in this modern JavaScript, so in this ES6 Plus, where transpiling comes in, as I mentioned earlier. Again, because it's not safe to assume that all our users are using these modern browsers, and we don't want to break our app for them, right? And by the way, if you want to stay up to date with what features are currently supported in which browser, you can check out the ES6 compatibility table. It's really interesting. The link is actually on my resources page on jonas.io. Next, there are also the future releases of the language, like ES 2021, ES 2022, and so on. And these future releases together are many times called ES Next. Now, why is this even relevant? Well, because most browsers actually start implementing new features even before they enter the official ECMAScript specification. That's possible because as new features are proposed, they have to go through 4 stages, starting with stage 1, where they are first submitted, all the way to stage 4, at which point they enter the language officially. But when a feature is at stage 3, browsers can be pretty sure it will eventually pass to stage 4, and so they're going to start implementing that feature while still in stage 3. And there is a lot more to be said about this, and actually I find this really fascinating, but I'm going to stop here. You can find tons of information about this online if you want to learn more. And a great place to start is actually, once more, this compatibility table that's up here on the slide. But anyway, as these new features start coming out, I will simply add new videos about them to the course in order to keep it updated. With the annual release cycle, this is now way easier to do, because there will be no drastic changes to the language like ES6 was. Okay, and now to finish, let's quickly talk about how versions, or releases, are taught in this course. So as I said earlier, I will teach you modern JavaScript right from the beginning of the course. Now, I used to teach this course starting with ES5 and then moving to ES6 in the middle of the course. But now, after a couple of years, it was time to fully move to modern JavaScript. However, it's also super important to learn how some things used to be done before we had this fancy modern JavaScript. For example, in this section, I already showed you the modern const and let for variable declarations, but also how we used to use var before. And there will be many more examples like this. But why bother with ES5 at all, you might ask? Well, here is why. First, you will better understand how some features in JavaScript actually work behind the scenes. For example, ES6 classes, which hide all the implementation details of object-oriented programming in JavaScript. Also, many tutorials and example code that you will find online are still written in ES5 today. Plus, as a developer, in many jobs, you will actually have to work on older code bases, and it's totally possible that that code base might still contain a lot of ES5 code. Okay, so I hope that made sense, and that's it for this lecture and for this section, so see you in the next one. Now that you're familiar, and there will be many more examples like this. But why bother with ES5 at all, you might ask? Well, here is why. First, you will better understand how some features in JavaScript actually work behind the scenes. For example, ES6 classes, which hide all the implementation details of object-oriented programming in JavaScript. Also, many tutorials and example code that you will find online are still written in ES5 today. Plus, as a developer, in many jobs, you will actually have
let's now take functions even one step further and calling one function from inside another function. And this is something that we do all the time in JavaScript, but I have seen many beginners.
It's very simple.
Beginners struggle to understand this logic. And so I created a specific video just for this topic. Go back this function calls and return a JUnit that first cuts the she starts by writing into more. Okay, so that props in pieces will be also cut fruit pieces, but we call it with the oranges. Okay, and so for the first time now we called one function inside of another function. So if we now call fruit processor with 2 and 3, then this will call the fruit processor function, which then in turn will call the cut. To finish this part about functions, let's review everything important that we learned so far in order to make sure that you really understand functions before we move on to other topics. And let's start by bringing back JavaScript has some built-in functions that we can basically apply directly on arrays. And these are called methods, and we can think of methods as array operations, basically. So let's now learn some useful array methods. And there are actually countless array methods in JavaScript. And in fact, we have a whole section dedicated to arrays alone. That's how important they are in JavaScript. But in this video, we're going to learn just some basic ones that you really need to know. And also so that you start to get used to the idea of using methods on arrays. Now let's start by bringing back the friends array from the last lecture. All right. And now let's start with a method called push. So the push method adds elements to the end of an array. And so let's say friends dot and then push and then the element that we want to add to the end of the array. So let's say j here. So push is essentially a function, and we can see that by these parentheses. So it's a function that we call, and we call that function really attached to the friends array itself. And that's what this dot here stands for. All right. So again, push is a method, which technically is a function, and we call that function directly on the friends array. So the push function is kind of attached to the friends array. And if you're wondering why that is, we will once more learn that a little bit later in the course. But there is a good reason why this works, and it's actually pretty fascinating stuff. So I hope that you're excited to keep continuing to explore this course until you really learn how all of this actually works. Now anyway, so I hope that you're excited to once more learn that a little bit later in the course. If you're wondering why that is, we will attach get self, and that's what this dot here stands for. All right. So again, push, and we call that function really attached to the friends array itself, and that's what this dot here stands for. All right. So again, push is a method, which technically is a function, and we call that function directly method. Function a push is essentially, and then the element that we want to add to the end of the array. So let's say j here. So push is essentially a function, and we can see that by these parentheses. So it's a function that we call, and we call that function really attached to the friends array itself, and that's what this dot here stands for. All right. So again, push is a method, which technically is a function, and we call that function directly on the friends array. So the push function is kind of attached to the friends array. And if you're wondering why that is, we will once more learn that a little bit later in the course. But there is a good reason why this works, and it's actually pretty fascinating stuff. So I hope that you're excited to keep continuing to explore this course until you really learn how all of this actually works. Now anyway, let's now check out the friends array in the console, because this is really all we need to do to add an element to the end of the array. And indeed, now we get the original array that we had before, plus the j element. And you see that the length is now also 4. Okay, so this actually changed, so it mutated the original array, but that's no problem at all, just like I explained to you in the previous lecture. Remember that? All right. Now, since push is a function here, it can also return something. So we already know that we can pass arguments into functions, and we did that here with j. Then the function can do some work, and in this case, the work that the push function does is to add the elements to the array. And actually, the push function does return a value, and the value that it returns is the length of the new array. So if we want to capture that data, or that value, we can create a new variable for that. So let's call it new length, and let's then also log it to console. And indeed, it is 4. So most of the time we actually don't do this. So we just push an element and call it a day, because usually we don't immediately need the length of the new array. But in case we need it, we don't need to then calculate it separately. We can simply take the result of this function here, store it into a variable of the array. So again, let's check it out. And the unshift method also returns the length needed. And then we have some to remove. This means that pop will remove the last element. This time not needed really in that, but from here. And we could do the same for this first call, but as I said, I want to show you Peter. And so element that's then, here it is, first element. Because I did a mistake. And then we pass the element. So let's check that. So friends dot includes, and now, and since 23 the string is different, there are many more useful methods for manipulating arrays, but for now I just wanted to show you the most basic ones. And next up, there's yet another coding challenge waiting for you. So after arrays, it's now time to learn about another data structure in JavaScript, which is objects. So up until this point, we have been using arrays as a data structure to basically store view of structure with the array. Objects to in this video, you're going to learn how to retrieve data from objects and also how to change data in objects using both the dot and the bracket notation. So let's another example, which I think is going to be really fun. So let's say that we which is at Jonas Schmidt. Let's keep exploring objects, and this lecture will bring us to object methods. So we learned that objects, just like arrays, let's simply add. So here we have a string value, here we have an array value, here we have a boolean value, and here we have a function value. All right? So I hope that's logical. And now, just like we can access any other property, we can also access the callH property or method. So Jonas.callH, and to call H, introduce you and then drivers. That's when we so for it's just a normal variable, and it's going to be available here inside of this code block. So let's transform this to a template string so that we can then insert that variable into the string. So we get rid of the hard-coded value, and now we basically dynamically build the string. And so here, all we need to do is to put the rep variable. And now we get exactly what we wrote here manually in the beginning, right? So that works. And so let's recap exactly what we did here. These days, everyone seems to be talking about AI tools for programming. Things like ChatGPT, GitHub Copilot, the new Cursor AI code editor, and so on. There's a lot of sometimes, and don't stop. Let's now learn about HTML attributes, classes, and IDs, and then also learn about a couple more different HTML elements. So what are attributes? Well, in HTML, some elements can have attributes, and these attributes basically describe elements. So let's, for example, create a link, and this link will be inside of this paragraph, okay? So as you already saw, we can nest elements inside one another for the body in that and inside on the page. So just like before. And of course, you can use your own link or whatever link you want to use. Okay, and then we can go back and we're back on this page. Okay, so that's what we used this href attribute for. We described the anchor element by telling it which URL it should go to whenever we click on a link. Now here on the page, you can actually see that this text here, so this link, is right in line with the previous text. So the text here
Two years ago, Cursor 1.0 was released as a VS Code fork that helped you autocomplete your code with AI, like an airline copilot. Then 6 months ago, the Cursor 2.0 was released, with an upgraded chat view that could take control of your terminal to build entire features, like an airline captain. But then, just a few days ago, Cursor released version 3.0, and this version doesn't even want you writing code anymore. Instead, it wants you to be more like an air traffic controller running swarms of AI agents across multiple repos, machines, and even the cloud at the same time. On top of that, Cursor just released their new Composer 2 model, which was allegedly trained in-house and is more intelligent than Claude Opus 4.6. That is, if we are to trust these Trust Me Bro benchmarks. But what's even more crazy is that Cursor is not even a VS Code fork anymore and has been completely rewritten from scratch with Rust. That's great news for your RAM, but not everybody is vibing with the new direction of Cursor. And in today's video, we'll break down its controversial new features. It is April 6, 2026, and you're watching the Code Report. Before we can talk about Cursor 3, we first need to talk about Composer 2, which is Cursor's new in-house coding model. When it first came out about 2 weeks ago, it blew our minds because its numbers on the Trust Me Bro benchmarks were off the charts. Intelligence exceeding Opus at a fraction of the cost and at a much faster speed. Better in every way, which is crazy for a new frontier model. But just as NASA tricks globetards that were going to the moon again, the Cursor was a little bit tricky about how they portrayed this model to the vibetards. What they initially failed to tell us is that Composer 2 is in fact based on Moonshot's Kimi K2 model, and we only realized that after someone found its model ID in Composer's metadata and posted it on Twitter. That's kind of funny because Kimi itself has been accused of training on Claude's outputs because it will occasionally say, "Hi, I'm Claude." Cursor later apologized for not being transparent, and even though it is just Kimi with some really good reinforcement learning, they released a full technical report on how they did it. But none of this drama really matters because a model that's smart, fast, and cheap is going to be extremely valuable in the zero-code future of programming. But to optimize the shift from code to agents, they completely rewrote the new interface in Rust and TypeScript. To be clear, the old antique VS Code editor is still there, but this new interface is more about managing agents, so you can almost entirely ignore your code base.
Because coding agents are getting so good. It's a home for your agents, and it combines the power of a professional development environment, language servers, files, remote SSH, with all of the models, and the ability to run as many agents as you want, anywhere.
Many have criticized this as being too similar to OpenAI Codex, but now let's find out how it works in a real-world project. After I introduced Horse Tinder a few weeks ago, venture capitalists have been stampeding to fund it, but now I need an actual prototype. Coding it by hand would take months, vibe coding it would take weeks, but with a swarm of agents, I can bang it out by the end of this video. I'm starting with a fresh project, and the first thing I might want to do is enter plan mode to have it work out a basic architecture. While it's doing that though, I can do other stuff in the background, like maybe I want to have it start working on a separate landing page for marketing, or maybe I want to SSH into a cloud server and have it do remote work on my server, or maybe I just want to switch to an entirely different project and spin up an agent there. Well, I can do that all seamlessly and work with multiple agents in parallel directly from this window. We can monitor the status of each agent, and when we get a yellow dot, it means we need some extra human input, typically to grant permission to run some unsafe commands on your system. But if the dot turns blue, it means that the work is completed and it's ready for review. After a few minutes, we already have 13,000 lines of code to work with. If we go to the right side here, we can then check out the Git history, we can open up a terminal, and we can even inspect the code in this minimal file explorer. But I think one of the coolest features is its built-in browser. Here, we can navigate directly to the app and play with the final product. As you can see here, it includes a perfectly rendered SVG graphic of a Clydesdale Hillsdale. But overall, the design is horseshit. Luckily, we can just go into design mode and start asking for changes. Like, I can't see the text on these green buttons, and instead of trying to fix the CSS manually, I just highlight the element and tell AI to fix it, and it gets the work done in the background. I don't even need to wait for the end result. I can just keep queuing up other fixes. And then after a few minutes of that, I built a billion-dollar social media company that will make the world a better place. But a company that's actually making the world a better place for developers is Blacksmith, the sponsor of today's video. It's a drop-in replacement for GitHub runners that lets you run your GitHub actions twice as fast while costing 75% less. That might sound too good to be true, but they're able to achieve this blazing speed by running your actions on bare metal gaming CPUs with the highest single-core performance. The Blacksmith also makes your GitHub actions fully observable, so you can quickly track down what's happening in your CI pipeline when something goes wrong, which is critical when you have agents writing thousands of lines of code with no parental supervision. Try Blacksmith for free today at the link below, and you'll get 3,000 free minutes per month when you sign up. This has been the Code Report. Thanks for watching, and I will see you in the next one.
Yeah, makes sense.
Backend engineering is a very wide scope. And when I say backend engineering, it is much more than building a set of CRUD APIs. The way I think backend engineering is about building reliable, scalable, fault-tolerant, and maintainable code bases and efficient systems. And if one were to start today to learn backend development, there are a lot of resources and at least 1,000 resources. But how do you decide what to learn? How do you prioritize? How do you see the big picture? When and how all these different concepts come together? And this is the reason it takes people years to get their head around a lot of these concepts and principles. Because people primarily start with a limited scope of training, whether it is from a college or a bootcamp or a simple API course. And they eventually build on top of that with trial and error and with help of other developers over time. Now, I am a backend engineer, and I have faced this struggle initially when I started out. I have to constantly search for resources, learn from other developers. I have read a lot of books on backend development. I have studied hundreds of open source code bases. To see how people in the industry are building stuff, and it was a very time consuming procedure. And the second problem is people start with backend development from a particular language or framework's point of view. It could be Express or Spring Boot or Ruby on Rails, and the problem with that is you look at the problems that you solve with the lens of a particular language and ecosystem, and there are blind spots in that. Let's imagine you have to switch to a different language. Let's say you were working with Ruby on Rails for years, and one day your company decided to migrate to Golang for performance reasons. In that situation, how much of your knowledge can you transfer if you don't understand the underlying systems? So here I have decided to put together a comprehensive list of videos which are based on foundational concepts of a backend system. And these are from various books that I've read over the years, the open source code base. We'll start with a very high level understanding of how backend systems work behind the scenes. We'll look at how a request from the browser flows through different hops, the network firewalls over the internet, and how it is routed to our backend server that is situated in a remote AWS server, and how it responds to the request, and we'll look at what the response looks like. And that should give us a pretty vivid idea of how systems communicate, how a client communicates with the server, and how the server responds. From there, we'll move to understanding HTTP protocol. What is the role it plays, and how the communication is established through HTTP, and how HTTP raw messages look like, and what are the HTTP headers, what are the role of the headers, the different types of headers like request headers or representational headers, general headers, and security headers. And we'll look at different types of HTTP methods like get method, post, put, delete, and when to use them, and what are the semantics and what are the principles behind them. We'll look at what is the core flow and how does it work. We'll look at how simple request differs from a pre-flight request, and how a pre-flight request flow looks like. That server returns, and when to return which type of code, and what are the most commonly used HTTP status codes. Then we'll look at HTTP caching. What are the different types of caching techniques using HTTP? We have E tags, we have max age headers. Then we'll look at the differences between HTTP 1.1 and HTTP 2.0 and HTTP 3.0, and what are the differences between them. We'll look at how content negotiation looks like between client and server using different headers. We'll see how persistent connections work in HTTP. We'll look at HTTP compression, different types of compression techniques like gzip and deflate and br, and which is the commonly used technique. We'll see the security aspect of it, the SSL, TLS, and HTTPS. Then we'll move on to routing, how routing maps URLs to server-side logic, and what is the connection between routing and HTTP methods. Different components of routes like path parameters and query parameters, different types of routes, static routes, dynamic routes, nested routes, hierarchical routes, catch-all, wildcard routes, and regular expression-based routes. How to do API versioning using HTTP, different types of versioning techniques. We'll see what is the best way to deprecate a route and what are the best practices in the industry. We'll look at the benefits of route grouping and how it helps with versioning, permissions, and shared middleware. We'll see how to secure routes, how to optimize route matching performance. Then we'll move on to serialization and deserialization. This basically means how, before sending it over to the network, our server translates the data into a particular format, and after receiving the data from let's say client over the internet, and how it translates the data received from the client over the internet to its own native format. It is called deserialization, and we'll see what is the need of it and how it helps with the interoperability standard. The different formats that are used in serialization and deserialization: we have text-based formats, which is JSON or XML. We have binary formats, which is protobuf, and what are the performance differences between these two, and when to use which one. We'll look at how different programming languages implement serialization and deserialization. We will explore a popular text-based format for serialization and deserialization, which is JSON, the structure of JSON, or JavaScript serializing. Look at the security concerns of it, like using format authentication, their token authentications, we explore F, XSS, and cryptographic technique, which takes a little bit of time, even though that's, for example, because string, but let's say we are expecting an ID field, which is a number. So before we send it to our, and all the issues, then is conditional validation. So let's say in the form there are two fields. One is partner's name, and the second is married, which is a boolean, true or false. So a partner field might only be required if the married is true. So that is a conditional validation. So these kinds of checks we have to do. Then there is chain validation, like converting a string to lowercase, then revoking special characters, and then checking its length. Then we look at error handling validation, like sending meaningful error messages to frontend so that the user can fix them. and aggregating all validation errors in one response for client-side display or obfuscating error messages. So instead of saying invalid password, we'll have to say invalid credentials to prevent different types of attacks. Then we'll see how to gracefully handle failed transformations, for example, an invalid JSON and a failed date conversion, and how to let the user know in a meaningful message. Then we'll look at the performance trade-offs of validation and how to optimize it by returning early, avoiding redundant validations. Then our next topic is going to be middlewares. We'll look at what is a middleware and when to use them, what are the common use cases of middlewares, the role of a middleware in a request cycle, for example, a pre-request middleware or a post-response middleware, the flow of middlewares, for example, techniques like chaining. A middleware is executed in a sequence, passing control to the next middleware until request reaches its final handler. How to order middlewares appropriately. For example, we have to go in this order. We have to log the request, we have to check whether the user is authenticated or not, we have to do. Then we'll move to handlers and controllers. Well, strict validation, consistent response formatting, limiting payload, some of the theoretical concepts, querying or inserts or deletions, and business. And there is the hierarchical caching, which combines level 1 and level 2 caching strategies, where frequently used data is stored in a fast and implement retries in task queues. We'll look at task prioritization. After that, we have config management. What is exactly config management and how does it help with flexibility and decouples environments, ensuring that alerts are basis or long-running jobs. How it works, like long process, minimizing network overhead by reducing payload size, automate tests in CI/CD environments, how to manage code. We'll see what are the new features of OpenAPI 3.0 and 3.1, what are the tools surrounding OpenAPI, for example, Swagger UI, CodeGen, Postman, what are the best practices like avoiding duplication and sticking to standards. We'll look at a very interesting development method, which is API first development, where you define your OpenAPI standard or write your OpenAPI spec first, and then you start creating the APIs. After that, we'll move on to webhooks. What are the use cases of webhooks, like sending notification, third-party integrations? What are the differences between API versus webhook for the same use case? For example, for API, we might have to use pooling, which is client-side initiated, compared to webhooks, which is pushing, which is server initiated. What are the key components of webhooks? For example, the webhook URL, event.
Is the belief that there are enough resources, time, and opportunities for everyone to be successful, and the success does not come from the expense of others. India doesn't have an abundance mindset yet. It has what's called a scarcity mindset. The reason is obvious. We've always been a risk-averse country. We've never promoted taking risks. We've always looked down upon failure. But the best entrepreneurs, the best businesses, the best people are built out of a lot of failures. Remember, we're a strong country. We're as strong as iron, and no one can destroy iron, but its own rust can. One of the biggest reasons of scarcity mindset, one of the biggest reasons we don't like to see other people succeed, is because deep inside we know we won't. We know we waste a lot of our time on social media. We know we're not putting in the efforts in the right direction. We just hope other people aren't as well. Abundance mindset is the belief that there are enough resources, time, and opportunities for everyone to be successful.
Now, before we get to the meat of it, I wanted to know exactly what to expect from these videos and how to learn from them. So let's get our expectations clear. In this particular playlist, which you are currently watching, I want to tell everyone the story of backend engineering, the philosophies behind it, the big questions and the inner workings and the collaborations between different components and machines. The narration will help you see the big picture of a production-grade backend and help you appreciate the concepts that are abstracted by languages, runtimes, frameworks, and libraries that we use every day. So let's write it down. So this playlist is about the story and philosophy, right? And this is the first step towards being a backend engineer with language agnostic skills, right? Skills which are beyond frameworks or ORMs or any particular library that you use and work with every day. Once you have the foundations clear, once you start to see the common patterns behind every backend application and understand the philosophies, how the dots connect together, now that is the best time to talk about implementations. To see how all these principles come together to create a complete backend application and how all of them look and work in actual code. So let's write it down. Implementation. And this is the point where we have to choose our language, our ecosystem. And at this point, I am planning on releasing 2 versions, one in Node.js and the second one in Golang, since those are the 2 languages that I have first-hand experience in, that I work with every day. Now, in this phase, which will be again another playlist, we will pick each principle and deep dive on it in that particular language and the surrounding ecosystem. So in a way, most videos of this playlist will have an associated implementation specific video in the next playlist, right? For example, in one of the principles, we will talk about databases and drivers and migrations and all the concepts surrounding databases that backend engineers deal with day to day. So the Node.js and Golang playlist will have an implementation of that, where we deep dive on, let's say, Postgres with the JavaScript driver Postgres.js or the Golang driver PGX and cover every single concept around that. Now, in the third phase, this is where everything comes together. All our concepts, all our language-specific deep dives, all our philosophies, and here we'll build production-grade projects from end to end with all industry standards and best practices. We'll build quite a few of these projects, which you can follow along if you want. So let's slide it down. Production level projects. Right. By the end of the journey, that is if you decide to take it, and if you internalize everything and follow along with all the projects, you should be safely able to call yourself a backend engineer, and you should be able to go out there and build real systems that scale, systems that start from 0 users and scale to 1 million users, systems that people can maintain over a long period of time. So with those expectations, let's start. Let's check. Backend, in its traditional definition, is a computer which is listening for HTTP or WebSocket or gRPC or any other kind of request through an open port, whether it is 80 or 443, which is accessible over the internet, so that clients or other frontends can connect to it, send data to it, or receive data depending on the kind of request. And we call it server because it provides or it serves some kind of content, whether it is static files like images or JavaScript files or HTML files, or it could be JSON. And it also accepts data if this client sends something. Now that is a fair definition of what a backend is and how it works. But I want you to get a holistic view to actually see the components physically, how they work behind the scenes. So let's go through this whole flow. Now I have a backend server which is deployed in AWS. So let's take that as an example. Users. And there is some sample data the backend is serving. So let's do it one more time. And this time open the network toolbar, and if we refresh one more time, let's disable cache so that we get the appropriate status code. Alright, so this is the request which starts from a browser and reaches our server, and we receive this response. Now we'll cover request and response in a later video. For now, let's look at how the whole flow looks like. So let's trace it out. Let's trace how our request starts from a browser and reaches our server. So the first thing that you can see is the domain name. So if you can see it, this is the domain name, streamlessly.xyz, and this is a subdomain. So the first thing that comes to mind is we should take a look at our DNS server. Now this is my DNS server, and this part is the important part where we have defined different types of records. Now DNS itself is a huge topic, so instead of going too deep into that, I'll just give the basics here. Now to oversimplify it, DNS has different types of records. You can use A records to point to a particular IP, and you can use CNAME records to point to a particular domain name or subdomain, right? So along with my other existing domains and subdomains, the thing to focus here is this part. Now if you see here, we have two A records, and one of them is backend demo, and it is pointing to a particular IP address. And where is this IP address coming from? So this IP address is of an EC2 instance which is in AWS. Now this is my AWS console. Let's go to EC2, and then let's go to instances. And this is the deployed instance. Now, if you see here, this is the public IP address that we just saw in our DNS config. So that particular subdomain, which is backend demo, points to this IP address, and our request reaches here to our EC2 instance through this IP. And before it reaches our server or the particular computer, it goes to a firewall, which is the AWS native firewall. The firewall has to allow some kind of request to go through. Now, if you look here, this is the security group that is assigned to our AWS instance, which basically means that using this, we can specify what are the ports we want to allow. What are the ports that we want to be accessible over the internet, right? So you can see we have allowed 3 different kinds of ports, and we use this port to log into our AWS instance through terminals or command prompt, so that we can do different kinds of operations. And the HTTPS and HTTP ports. Now this is the important part. Our request goes to the domain server, which points to our AWS instance IP, and through the IP it reaches the AWS instance, and before going into the computer, it passes through these firewalls. So if we don't allow these two ports, like 443 for allowing HTTPS traffic or 80 to allow HTTP traffic, if you don't allow it, the AWS will block it right here, and our request won't be able to reach our server. So this is an important part. And finally, after this, our request reaches to our computer. Now, after our request reaches here into our AWS instance, we are using something called a reverse proxy, which basically means it is a server which sits in front of other servers, so that we can manage different types of redirects or configs from a centralized place instead of changing the configs in every single server. So for that, we are using Nginx, and this is how our config looks like. There are a lot of stuff here, but the parts to focus here is we're using something called a certbot to assign SSL certificates automatically, but not something to worry about in this demo. The parts to focus here is it is listening for port 80 in our AWS instance, and it is redirecting that request to port 443, so which is an HTTPS request. So that part is managed by certbot, and the part that we have configured is this. So what we're saying is, this is my domain name, so we can define it using the field server name. This is our subdomain, backend demo, and whatever request that comes to this domain, so which is already routed by a DNS server, so it will reach this instance. So that is not something you have to worry about. And what we're saying is, whatever request that comes to this domain, our Nginx config will redirect those requests to our localhost 3001, which is the port our server is running on, our node server is running on. And this is the final redirection. So if we take a look at our processes, let's do PM2 list. We are using PM2 to manage our processes. So we can see here that we have 2 processes running, one for frontend and another for backend. and this is a node server. So this is the final hop. And if you want, we can also check this. If you just do curl localhost 2001/users, and we will get the same response. So from the point of view of this instance, our server, our node server, is running in localhost, and we are using nginx and domain names to route requests to our local server over the internet. So if we were to summarize, our request starts here in the browser, it goes to our DNS server, then that goes to our AWS servers, and it goes through a firewall, and that reaches our AWS instance, right? And that request is then reaches nginx, and that finally forwards that request to our localhost 3001, our final server. So it goes through all these hops until it finally reaches our server. So when we're developing in our localhost, you can just open your browser and go to localhost 3000/users, and you'll see the same response. And we saw that in our AWS instance also. If you call to our server, we'll get the same response. Now you should have a fair idea of how a request looks like and how a request travels over the internet and reaches our server. But why exactly do we need these backends? I'll give an example. Imagine you're scrolling through your Instagram feed and you come across your friend's posts. As usually, you like them. You click on the like button. And on the other side, your friend gets a notification that you like their post. So between you clicking on the like button and your friend getting the notification, what exactly happened? Now that is where the concept of backend comes into play. You click on the like button, the app sends a request to the server. The server parses that request and sees who is the user, and it finds your name or your ID or whatever. And then it persists and saves that the data, the action of you liking it. The server has to save it in some kind of way, usually in a database. It saves that information, and then it checks who is the user whose post you liked, and it finds that user's ID, and it sends a notification. It triggers some kind of action that sends a notification to that user, and the user gets a notification in their phone. So all these interactions that happen between you clicking on the like button and your friend receiving the notification, there has to be some kind of server, a centralized computer that has to have all kinds of information about all the users. Because if you look at your app, it is designed, it is customized according to your needs and your profile and all the people you follow, right? And all the actions that you can perform on your account. Similarly, that is the case for your friend. They only receive the notification that is intended for them. But the server has to have all kinds of information, right? All kinds of information of all kinds of state. So it has to be centralized. And from whatever we have seen till now, if you try to condense down and if you try to strip it down the responsibility and the use of backend to a single word, it will be this: data, right? The need to fetch data, the need to receive data, and the need to persist data somewhere, and any kind of actions and every kind of action that deals with data. And if you ask me, why not just do everything on the front end, right? Since that is also some kind of device or some kind of computer depending on what you are using. So why not do it here? Why not connect to the database here, and why not do every kind of actions that servers do? And since everything is distributed everywhere, we'll have better performance, right? Technically. And that is an excellent question. So in order to understand that, why can't we use all those functionalities in frontend? You have to see how frontends actually work behind the scenes. Now, like our earlier backend demo, let's do a demo for how frontend works from end to end. This is a Next.js application that I have deployed in the same AWS EC2 instance. Open the network toolbar again, and let's hit the refresh. And what we see here is the first document that the browser fetches. We look at this, it calls this domain name, and if you look at the response, it is an HTML file. The browser fetches the HTML file and all the resources, for example, all this JavaScript and all the images, the fonts, and the CSS files, all of those different things are fetched in different requests after we have our primary HTML file. And in our record, we see that we have an entry for this subdomain, which is frontend demo, and it points to this particular IP address. And if you trace that, we land here, which is the AWS EC2 instance, and we can see that this is the same public IP address. Next, as usual, the port 443 and the port 80 has to be allowed for HTTPS and HTTP traffic to get through to our server. And finally, the request lands here, our EC2 instance. And if you look at the nginx config, this is what it looks like. Again, most of the things are the same as it was in our backend server. We have the same server configs, but the thing that is different is here we are listening for this domain, which is the frontend demo, and whatever traffic that comes to here, we are redirecting to the localhost 3000. Instead of redirecting to 3001, we are redirecting to port 3000. And finally, the request reaches our frontend Next.js server, which serves the files, which is the JS file, the CSS file, and the HTML file, which are sent over the network to our browser. And after going through all of that, after we receive our main HTML file, what the browser does is it goes through all these resources, the JavaScript files, the CSS files, and the fonts, and it fetches them one by one. Once it fetches all the CSS, which you can see here, it paints our window. That's how we get all these styles, the background black and these fonts and these button styles. And once the browser fetches all the JavaScript files, that's when it hydrates all the event listeners for buttons and any kind of interactions that we have in this page. For example, if you click on this button, this is what it happens. It redirects to another page. That happened because the browser fetched all the JavaScript, added all the event listeners, and that's how the button started working. So what do you notice here? Whatever front-end logic that you have written, whatever the JavaScript that you have written, is all fetched by the browser from our server, and it is executed by the browser in our machine, in client's machines, right? So the browser is our runtime compared to our traditional backends, which we saw earlier, the one in AWS EC2 instance, where we sent a request, the server processed the request and sent us the result. So the actual processing happened on the server, right? And it is exactly the opposite for frontend, where it sends us the code, but the browser runs the code. Whatever logic that is run, it is run by the browser. So that is a key difference to notice here. Now, there are a couple of issues that we find here, right? Because browser runtimes are often sandbox environments, which means they are isolated from our operating systems. The processes and the file system, everything is an isolated environment, which means the code can only access limited amount of resources. For example, the DOM, which is the document object, and browser APIs, for example, local storage or cookies, and external APIs, but only if the external API has all the required amount of headers. We have not covered CORS yet, which we will in a future video in much more depth. But you can imagine CORS as a policy, a security policy of browsers which restricts JavaScript code to call external APIs, which is not the same as the current domain. For example, we have this frontend app in this domain, which is frontend.xyz. So we can only call resources, or we can only fetch resources and call external APIs, which are in the same domain. If we try to call a different domain, then the browser will block the request because of CORS policy. And there are ways to get around that, which are through HTTP headers, which we will explore later. And if you think about it, all these sandboxing and security restrictions make sense, because essentially what a browser is doing is it is fetching code from a remote server and executing it in the user's browser. And if it's not careful enough or isolated enough, the remote code can easily access data or files from user's computer, which is not a good thing. For example, imagine you go to a website and you have no idea what is the front-end code of that website. And if browsers did not isolate environments, that code can easily get access to your file system, copy all your files, your sensitive details, and send it to their servers, right? So that is a very scary idea. That's why browsers have all the security policies. Now, coming back to our original question, why can't we write backend logic in frontend? So the first thing, obviously, is security reasons. Security reasons. Because the security policies of browsers are so restrictive, and oftentimes a backend needs to access underlying file system, whether it's to write to a log file or access environment variables, and browsers won't allow that. That is a huge restriction for a backend server. The second thing is, you cannot call external APIs whenever you want, unless that API has all the appropriate CORS headers. And since we don't have control over all the external APIs, this is also a big deal breaker, because backend servers often need to connect to other servers and fetch data from multiple places. So we cannot have this restriction. And the third thing is databases. Now, the server runtime has access to all native database drivers, for example, PG for Postgres and MongoDB, and that allows it to communicate efficiently with databases. These drivers are written to work in environments that can handle socket connections, handle binary data, and maintain persistent connections, things that browsers cannot do. And we will explore later how backend servers communicate with databases. But to simplify it, backend servers maintain a list of connection, which is often called a connection pool, to our database server, so that it does not have to create and destroy connections again and again, because backend servers receive thousands and thousands of requests in seconds, and if they do the connecting and destroying logic with each request, the database server is going to get overwhelmed and it cannot handle that load. So drivers are written in a way that can maintain a list of connections, and browsers are not designed to maintain persistent connections to databases. And even if they were, each user would need to open their own direct connection to the database, overwhelming the database server with too many connections. There is also no easy way to manage connection pooling or efficient query execution from the browser environments. Now, the last thing is computing power. Front-end applications, as we use them, are everywhere. It could be a smartphone, it could be a desktop, it could be a laptop, and any kind of environments that we can imagine. Even a computer which has a 256 MB of RAM and with a single core processor. And the user might not have enough computing power to perform some heavy business logic, and things will start to lag and sometimes break because of the load. So for that reason, if it's a centralized backend server which serves and caters to a large number of clients, we can easily increase its memory and CPU whenever we want, and we can easily delete the load. We can continue this list as long as we want, but this should give you a fair idea that keeping backend logic in frontend is not a good idea. That is assuming if we can do it in the first place. Great. Now we have seen what a backend is, why do we need it, and how does it work on a very high level. Now this is a very good place to be in before we start our journey of learning backend engineering. Now let's explore what are these principles and why we should learn in this particular way. Imagine you are a newly joined software engineer, perhaps a front-end developer by trade, and you've been asked to fix a bug in the backend code base. And what are some challenges you can face? Probably the backend is is written in a language you're unfamiliar with, or maybe it's a language you know. But the bigger question is, where do you even start? Where do you look for the issue without getting lost in the complexity of the code? Or let's imagine you've been tasked to create an API from scratch. In this situation, how do you form the mental map of the code base, stick to the standards, and ensure you're not breaking anything? One scenario could be you are a backend engineer in TypeScript or Golang, and you're suddenly asked to jump into a different language, let's say Rust or Python. Now, how do you get up to speed quickly without wasting hours looking through docs of different libraries, let's say Fast API or